Hello, everybody. Nora here. This is a recorded version of the session on data modeling, specifically data modeling for relational databases. The audience of this session is people who have already collected data from their primary sources and need kind of a long-term plan on how to organize all of their data. I think the data modeling is one of the solutions on doing creating long-term plans. Specifically, I will introduce two visual techniques that would help you to think about your data. The first one is on the more conceptual level of how to approach your data, which is the ER model or entity relationship model. It is a model that helps you to identify the most important subjects that your data is supposed to describe, and also helps to map out the different properties and relationships between your important subjects. The second model will be on the more logical level. What does that mean? Relational model, very aptly named, helps you to think about how to translate all of your conceptual plan into tabular data and how to link up these different tables appropriately. Data modeling also covers the physical level which means like very specific plans on how to express your data. Think about like if you want to say that a birthday, for example, is represented by month, day, year, or year, month, day. But because this is a more because this step depends more on the tool that you're using, we're going to only focus on those two higher levels. Before we start, I would like to give you a couple of key reminders when it comes to data modeling. One thing is that there are different ways that, besides like structuring data into tables, there are also different ways to do so. There are databases that are graph-based, document-oriented, or object-oriented. Just be aware that they exist and that they might potentially be more suitable for what you want to achieve. The second key reminder is when we do data modeling, when we do those exercises below, and when you're going to make your plan on how to organize your data, just keep in mind that don't worry about whether you're modeling the right or wrong way. The thing is that the quality of a data schema doesn't depend on what you decide to record or what you decide not to record. Actually, a good data model is a result of your awareness and reflection of what shapes your decisions in the first place. The truth is that if we're going to be honest, there are infinite ways to describe something in reality. And a data model or any model is just a reading of these of the things that you want to describe, or a approach to these things you want to describe. So a tip that I can give you is that before you actually do the data modeling from the conceptual to the logical level, always consider your context first. So before you actually map out what you want to record, ask yourself the following questions. Why do I use this data? Why do I need this data? What do I want to achieve? How does the data serve my research? Is it for retrieval, curation, or analysis? Is it to say what kind of key questions in my research do the data is the data supposed to answer or at least to address? And last important question is like, who is your audience in the end of the ride? All these reflections, all these considerations about your context are much more important on what you're going to record, because it kind of shapes the decisions on how you will organize your data. Third point and final point, remember that data modeling is an iterative process. So it's not something you only do it once, but you have to revisit that. It means that you will revisit your model time and again, whether we're talking about like different draft versions before you set out to put your data into tables, or whether you're dealing with a primary source that that kind of doesn't fit in your model, and that you need to consider whether you try to change the model to accommodate a particular aspect of the source, or whether you want to make the source adaptable to your model, etc. With that all being said, let's jump in and start with conceptual data modeling. We will, of course, start with the context because that's the most important thing. And from there, I will teach you how to do the ER model, entity relationship model. So, ER modeling. Every conceptual data modeling starts with writing. What do you write? Well, what you want to describe, like your objects, and you also write like how you see these objects, and also, very importantly, what you think to expect when describing your objects. If this sounds vague, I have an example for you. Suppose we are a project manager that plans academic conferences for a living. We have done many conferences and will plan many conferences. So it is good to keep track of the activities and people in a database where I can retrieve the information, analyze the information, etc. Now, there are many ways to describe a conference, but in the mind of maybe a project manager, it could look like this. Like if I need to keep track of a conference, I will define it as a large event that has the following properties such as name, like I want to keep track of the announcement poster, and maybe of the organizers of the conference. And of course, a conference is a bit too vague. Maybe I want to go a little bit on the down level and assume that most of the activities that I want to track are presentations. So I can define like, okay, a conference is a large event that hosts a series of presentation. And since I have to share data maybe with people about this presentation, I might have to keep track of certain properties of a presentation. For example, the title, the time interval in which it takes place, the place where it is being held, and maybe I have to keep track of the presenter. And I assume in my model that every presentation is given by one person. And since academic conferences are basically like a way to discuss papers, I assume that every presentation is about one paper. And since I need to exchange maybe also information about that with other people, I assume that maybe the most relevant kind of information might be the title, the abstract, the keywords that are attached to that presentation, as well as the author or authors of that of that paper. And of course, like last but not least, probably, are the people in the conferences. Now, I can keep track of the presenters that give the presentation, but I think maybe I should also keep track of the attendees. And if there are a couple of things that I need to know about a person attending or presenting at the conference, I should maybe keep track of their full name, maybe their birth dates, school affiliation, and maybe link up relationships between them, like who's supervisor of whom. Not now. The thing is that this is one way how I could model, describe a conference, how I think you should define it, what I think is important to track of. But maybe your model of a conference might be totally different. It all it depends actually on the context that you want to do. So after you're done writing, you can go over the text again and try to identify which pieces of information are objects or entities, as they are called in the entity relationship model, and which pieces of informations are attributes that you can use to describe the entities. Now you can see in this, you can see this is a visual representation of the text that I have here, and I have declared that conference, persons, presentations, and papers are objects that I want to describe, and the bubbles are all the different types of properties that I attribute to these entities. Now, you can already see that this is an early stage preview of what it might look like as of that it's an early stage preview of the tables that you're going to use to store the data. Each table is in the form of an entity, and each attribute can become a potential column in a given table. The next step that we need to do is drawing the relationships between the entities. Basically, it is going back to the text and see if there are verbs that links up the different entities. In my case of conferences, you can see that I have written that conferences are organized by persons, so I use the label organized by, put it in a diamond-shaped figure, and make it link between conference and person. And I do it the same for other relationships, for example, host that links up conference presentation, discusses that links up presentation and paper, etc. I think that is a very good exercise of mapping the relationships, because it actually helps you think about the attributes that you're using. In the previous rendition of this graph, I have identified people, for example, as an attribute in conference, presentation, and paper. But since I know that I link up all these entities to person, maybe that it's better to remove people as because it's a redundant attribute. What is noteworthy to know about relationships in this graph is that there can be multiple and different relationships between entities, and that an entity can have a relationship with itself. For example, you can see that the person entity has a relationship with itself through the label of supervises. After you establish the relationships, we give each entity a new attribute. This is called a key attribute, and it's just a unique number that would identify a particular instance of an entity. So, like if you have a certain number of conferences, it's always good practice to not distinguish them by their name and poster, but actually by their identifiable number. That being said, after we have established the relationships between the entities and given every entity their identifier, the next thing we have to do is use the relationships between the entities to think about the nature of the entities themselves. So we have to ask our question that does a entity need the existence of another entity in order to be identified properly? Or like the opposite, or a more simple question, like given the attributes, would that be enough to identify the entity on its own? Now the answer is like all the entities that we have here are very strong entities. We have a conference entity that can be identified by their name and poster, and despite having a relationship with person, it doesn't really need person to be identified. Same case goes for the person itself, the paper, the entity paper and presentation. Now, if you ask like, okay, so there are strong entities and there are weak entities, what happens if we have a weak entity? I will give you a better example of that. This is like an example of a strong and a weak entity next to each other. So let's pretend that we have to data a building, and we say a building consists of rooms. Every building has an architect and their year, and every room has its floor, its square meters, etc. We establish the relationship between them. Building consists of room, and room is part of the building. And we give each entity their identifier to distinguish the different instances. For example, building gets building ID, room gets room ID. Now the thing is that if I ask the question, if I'm modeling buildings and modeling all the rooms in the buildings, the thing is that if I want to identify a specific room, it will depend on the buildings that I've modeled. Because for the sake of argument, let's say that we have a campus and we have a lot of rooms, and every room follows the same kind of numbering, like ground floor is 0.1, another room next to it, the other room next to it is 0.2, the next one is 0.3, and this type of room identification is the same for for all the rooms in every building. Then you can already feel that it might be pretty confusing after a while, because if I say 0.1, then you might have to ask, yeah, but which building are you referring to? So you can already guess that room as an entity on its own is not strong enough, that it depends on the building to be properly identified. So in this case, it's a weak entity that needs to appropriate the building ID as its attribute. Now, to represent a weak entity in the graph, you have to make sure that the link between the verb, between the label of the relationship and the rectangle, that it has a double-lined link, and that, how to say, the building ID is also part of the room entity. So this is an example of a weak entity. So this is actually an example of a weak entity and a strong entity. And it also is a way to think about how you deal with weak entities as you structure them into tables. So we arrived at the last part of creating this graph, which is just categorizing the relationships between entities. The categorization is based on the question of how instances of one entity relate to those of another, that like of another entity that the one entity is linked to. Now, there are three types of relationships between the entities. I'm gonna take out a specific example from the graph and discuss them one by one. The first relationship that I want to discuss is host. The second one is attends and discusses. So the first type of relationship is what is called the one-to-many relationships. Now, go back to the text. Like, I have written like about the relationship between conference and presentation, namely that a conference hosts presentations. Now, the question would be like, what are a little bit the expectation? Is it like that a conference can host only one presentation or many presentations? Now, in this case, it's many. And if I look in the other direction, would a presentation only belong to one conference or to multiple conferences? Now, in my data model of conferences, I think that I assume that presentations can only take place in one conference. I don't expect them to appear in multiple conferences. In this subset of the graph, I write that conferences hosted n, which is just undefined number of presentations. And I also write that presentation belongs to only one conference. The second type of relationship is the one-to-one. Now, if I look back in the text, I write the assumption that a presentation can only discuss one paper. That's my assumption, and that one paper can only appear in one presentation. Now, in this case, I have to note that in the graph, like presentation discusses one paper, paper is discussed during one presentation. That's how I declare that this is a one-to-one relationship. The final relationship is that if you have a one-to-one relationship, one-to-many relationship, there can also be probably many-to-many relationship. In the case of the relationship between person attending a presentation, I always assume that a person can attend many presentations, and that in the other direction, that a presentation can be attended by multiple persons. So this is already like a little bit it seems to be a little bit of a complicated relationship. So this is the final version of my graph. Like with all the labels in place. Now, the next question that you probably are asking is like, okay, I have categorized all these relationships, but why? Like, why do I need to do that? I don't really see the point. Keep this in mind. This graph is like a preview of the tables you're going to use in order to store your data. Every entity becoming a table and every attribute of the entity becoming a column of that table. The thing is that by looking at these relationships, like many-to-many or one-to-ones, they give you a sense of idea if you need an additional table or don't need an additional table to link these tables. So, relational model. The thing is that when you have a table, tables consist of rows that should be unique in observation, and every observation is described by the number of columns or like the attributes, as you can call them. And the thing is that it's now easy. It's of course easy to create tables that have their attributes, but the next question is like, how do we link up tables that are supposed to be linked to each other? Well, here is the thing. In practice, you have to use the primary keys of the tables. What are primary keys? I think you already know them. They're actually the key attributes, which is conference ID here and presentation ID there. Technically, I could integrate all the information of conference into the presentation table, but like I can do it for every time, like in order to make sure that those two are linked. But the problem is like after a while, like one of the dangers is that if you are going to integrate each time the conference in the presentation table, you have to make sure that the information that you have here is consistent for every type of row. And in order to avoid it, in order to make your life easier, it is better to, create an additional field that incorporates the conference identifier. But of course, like that is how it mostly works. Like if you want to link up tables, you have to reuse either identifiers from another table, or if it is becoming too complicated, you can create an additional table that would incorporate the two ideas together. But the question is like, how do you know what keys to reuse and where do you reuse them? If there are two linked entities, should I put the conference identifier in presentation table, or should I put the presentation identifier in the conference table, or should I make a separate table? Well, the thing is, this is where the categorization of relationships comes in handy. Like it kind of gives you an idea of how to place the identifiers. In this case, of the conference and presentation table, we know they are linked up through a one-to-many relationship. One conference can have multiple presentations, but one presentation can only belong to one conference. Now, it could be that you could place the presentation ID in the conference table, but the problem is like, because a conference has to host many presentations, like you have to then create a lot of fields to incorporate the presentation ID. So that's not ideal. However, if you incorporate the conference identifier in the presentation table, then it is less of a problem because you only have one conference ID per presentation. So in order to reflect this kind of dynamic between the two tables, so in this case, you represent the dynamics between the conference and the presentation table by adding an additional field that hosts the conference ID. You write a name of how you declare the field in presentation, and then you use an arrow to refer back to the original conference ID, so that you know that the conference ID in the presentation table is a foreign key and not a primary key like presentation, and that this foreign key comes from the conference table where conference ID is the primary key. The next example of dynamics between table is the one between the presentation table and the person table. Remember that I categorize the relationship between these tables as one-to-one, so that only one person can give a presentation and the presentation can only be given to one. There is like a kind of a symmetry between these tables. So technically, what it means in practice is that if you ask yourself if you want to reuse a identifier from which table and where, like that it actually doesn't matter, that technically you could put the person ID in presentation, and or you can put the presentation ID in the person table. Now, I think that in my case for data modeling, since in the person table there can be multiple types of people, not only presenters but also attendees, that I think that it's better like to put the person ID as a foreign key in the presentation table, so that it's easier to have all this, that this type of information, relevant information, is for me in one place. I think that's the best way to organize my data. So what does that mean for cases such as the many relationships? So we know that persons can attend multiple presentations, and presentations can be attended by many people. This complicates a little bit. It would not be ideal to have a lot of fields for the presentation ID in the person table. It's also not practical to have a series of like different columns to capture the person identifier in the presentation table. So in this case, we will create a new table that incorporates the identifiers from both tables and add an additional identifier called attendance ID. So those are the three cases. So after going over every entity and to say every relationship, setting up a new table or reusing a identifier to declare as foreign key in another table, this is actually the final product. I hope this session is clear, and hopefully see you next time.